Hello students, outfit change for video 2. Get excited, this one's all about inverse trig integrals. So, I want to highlight these rules on the left. Remember these? It was inverse trig derivatives, or arc trig derivatives. So, if I say, hey, take the derivative of sine inverse, the result is this goofy function. If I take the derivative of tangent inverse, it's this other goofy function. And remember, these inverse trig functions can also be written as arc sine. So arc sine of x is the same thing as inverse sine of x. We learned those. They're on the back poster, so if you turn around and look at the back wall, they are on the derivatives you should know poster. On the right side, they're the second two from the bottom. Our goal for today is to go from the left side back to those inverse trig functions. So I'm going to give you something tricky. Your goal is to manipulate it slightly, get it back to those inverse trig functions. All of this will involve completing the square. All of it will involve completing the square. So let's do two examples. You'll see what I mean here in a second. Step 1. Is this a u sub problem? Remember a fun game of yes or no? If I took the derivative of the bottom, does that show up anywhere else? No, so it's not u sub. Thought number 2, can I do long division? Well, you just learned from the last video that long division only works if the degree on top is larger or the same as the degree on the bottom. And in this case, it's not, so the bottom's larger. So we have to do something different. That something different is completing the square. So here's how this works. You learned this in 9th grade. I know Mr. Dressel taught this to you because I've seen his lesson plans. We just have to complete the square on the bottom and then apply the inverse tangent rule. So, completing the square looks like this. Our goal is to say, I want to have a perfect sum of squares over here, and then I'll have some extra on the right. And anytime you see this, you're thinking, what is that unknown number that's going to go right here? And to find it, we say, what is b over 2 squared? So negative 2 over 2 squared. And so it's negative 1 squared is positive 1. That means positive 1 is the number that I'm going to plug in here. And if I add 1, I have to subtract 1 to keep things even on both sides. So I added 1 and I subtracted 1. And now let's simplify slightly to see what happens here. So I'm going to erase this. But remember, every time b over 2 squared, that's the number that I'm adding to both sides. So this is now the integral of 1 over, and here's where the sum of squares comes in, difference of squares, whichever one it is. I can now factor this. This is x minus 1 squared plus 9. So 10 minus 1 is 9. That's why it's called completing the square. I'm making that first chunk a square term. So now let's look back up at our formulas. So this is actually all you have to do algebraically. Now let's look back up at our formulas. We say, oh, heck yeah, which one is this? It looks to me a lot like this one. Arctangent or inverse tangent. And so in this case, a is the constant, a is the number, and then u is the function. So u is a function, a is a number. So what my result will be, it'll be 1 over, remember that number down below was a 9? Is it 1 over 9? No, don't be fooled. A squared, so it's got to be 1 over 3. So just like a circle formula, just like a, that's the only one I can think of off the top of my head. Anytime we've got this squared, we just take the square root. That gives us our a value. Same thing when we plug this in, the u is the non-squared version. So my result here is not the integral, because I'm doing the integral. the result here is 1 over 3 times either tangent inverse or arctangent, either one's okay, of x minus 1 over 3 plus c. This is our final answer. So again, the hard part is completing the square. That's a little tricky. And remembering the formula. Actually doing the integration isn't too bad, but the setup is difficult. So let's zoom out. Let's just see what we did. Step 1, at the very top, we recognized that we couldn't use u sub, we couldn't do long division, and we don't have a rule for this. So we had to complete the square on the bottom, simplify a little bit, and plug into our inverse tangent formula. These problems usually aren't too tricky on the AP test, but there's a chance that one could come up, so we just want to be prepped. Let's do another one that is not inverse tangent. This one's going to be inverse sine. So here's a new example. So step 1, can it be u sub? No, there's no negative 2x minus 8 term. There's nothing even close. Step 2, can I do long division? No, not even close because it's got a square root. This does look to me like it might be arc sine though. So check out this formula. It might be this one. And in fact it is this one. So this one is arc sine. We just got to put it in that form. So that's our goal for right now. So step 1, I'm going to move some terms around. And I'm going to group things in a certain way. So here's what I mean. I'm going to rewrite this as, this is 6 times the integral. So I'm going to put 1 on top. I like to do that just so I'm matching that formula, that setup exactly. So pull the 6 out. And now this is the square root. And I like to put my constant first, so negative 7 first. Since the formula up there said a squared minus u squared, and u is my function. So I'm going to actually factor out the negative also. So this is going to be minus x squared plus 8x. And I like to write it with that negative factored out, because that makes more sense in my brain when I'm completing the square. So that's step 1. Just rewrite it. Step 2. 6 times the integral of 1 over, now we're going to complete this square here in the bottom. So it's negative 7. Leave a little bit of room, because that's where you're going to add or subtract something. And then minus x squared plus 8x. And now we've got to figure out what to add and subtract. So remember, b over 2 squared. So in this case, b is 8x. So b over 2 is 4. 4 squared is 16. So I'm going to add 16. But this is tricky. Did I actually add 16? No, because there's a negative out front. So actually I subtracted 16. I need to add 16 out front here. That's weird. It looks like we're adding 16 twice, but for the one inside the parentheses, I added a negative 16 because that would be distributed to both. The one outside, I am adding 16. So this is a really weird quirk of this problem for sure. But remember, our goal is just to keep things copacetic. And I think we've done it. So toss your dx at the back end. Now we simplify, and it's going to look pretty dang close to the setup that we want. So let's simplify just a little bit. This is 6 times the integral of 1 over the square root of negative 7 plus 16. That looks like 9 to me. Excellent. It's a square number. Perfect. That's what I want. Minus, what's my factored form of this? It's x plus 4 squared. Toss your dx at the end. Now, this matches exactly what I see up above. So let's look up above. I'm going to erase some stuff here because there's actually a key difference I want you to look at. Arctangent does do 1 over a out front. Arcsecant does have 1 over a out front. Arcsine does not. There's nothing out here. I don't need to do 1 over 3 for arcsine. Every year somebody asks me, Mr. Bolkin, why is that the case? And I've tried to look through the proof of this, and I don't know. So if you do, let me know and explain it to me clearly, because I can't quite figure it out. Why doesn't there have a 1 over a? I don't know, but it doesn't. So that's our rule for now. With that in mind, let's write our formula. This is equal to 6 times arcsine or sine inverse of x plus 4 all over 3 plus c. And you're done. Again, the tricky part is not the calculus, it's the algebra and it's the recognition, right? So it's tricky to recognize that we got to use inverse sine and inverse tangent, but that'll be our goal here for the next couple problems. So those are your 2 examples. This key is filled out on your OneNote. What you're going to do next, and your sub will tell you this too, there's 2 questions in the OneNote that I want you to try. They're on the next page. And then you should check your answers in the key on the OneNote, or they might also show it on the screen. So good luck on those next 2. They can be kind of tricky, but remember what Mr. Dressel taught you back in 9th grade, and I know you'll do great. Hope this went all right today. Good luck.